This is problem number 11 from section 5.2. It says find a symbolic representation for f inverse of x. Identify the domain and range of f inverse of x. They give us the cubic function, and they want us to find that inverse, but first we need to make sure that this is, and this is not a cubic, it's a cube root function, my bad. So we need to make sure that the cube root function is 1 to 1. So let's put it in there. And I'm going to put it in there just slightly different. Instead of using the cube root button, I'm going to use just x minus 6 to the 1/3 power. It's the same thing. We know that a cube root means to the 1/3 power. Let's get the fraction bar in there. And let's hit the graph button. All right, and you'll notice here if we just draw horizontal lines, right, this thing is always moving upwards. We're never going to have our horizontal line cross twice. So this is 1 to 1. So that means we can start to solve for the inverse. First step, switch f of x and y. So we get y equals cube root x minus 6. So we switched f of x and y. Now we're going to switch x and y. So we get x equals cube root y minus 6. Now we're going to solve for y in terms of x. So we need to get y by itself. So we're going to cube each side. So we get x cubed equals the cube root y minus 6 cubed. When you cube a cube root, they cancel, so you're left with y minus 6 and x cubed here. We're going to add the 6, so we end up with x cubed plus 6 equal y. So we're going to write that now as y equals x cubed plus 6, right, just flopping the sides. And we're going to replace y with f inverse. So f inverse of x is x cubed plus 6. So that's the inverse. Remember, if you want to check the inverse, you take this inverse equation and we plug it into this original function. See if we end up with x when we simplify. And then take the original function and plug it into the inverse function to see if we end up with x after we simplify. Now, it wants us to identify the domain and range. What's the domain of this inverse function? This is a polynomial, so the domain is all reals. What's the range? Well, because it's a polynomial and it's a cubic polynomial, right? This is going off in either direction, right? Cubics, we know, look like this. So it's going off in either direction. So this range is going to go from negative infinity to infinity as well. So it's all reals as well. And those are the solutions.